For teachers, a day like today really gives us an opportunity to gather resources and ideas from other teachers and from the lecture materials as well for practical ideas in the classroom. It turns the lessons into more of a pupil-led sort of activity-based lesson.
So we're getting a lot of information about the national grid, about energy generation and supply, about the demand for it, and about the future and where we're going to go with electricity. What's different about this course is that we've put numbers to it, and we're making them think about the numbers involved. How many wind turbines must we have? How much generation can we get from them? And done that all the way through the alternative energies.
It's been very useful to pick up the book, especially to actually have those real life facts and figures about how much power can be generated in the various different alternative energy resources. It's something that we teach a lot, but it's very hard to know when you're teaching it how much it actually produces. That's going to be a really useful resource that I'll use in my teaching.
Well, the Model Oven is simply a way of engaging children to think about efficiency, which is there in the national curriculum. They're all required to do efficiency at GCSE. It's not the easiest of topics, it's mathematical, but I think children like to make things. So you can see where I'm leading with oven is about making food, and immediately has that connection to children. Plus the fact they're all familiar with ovens, they've all got one in their houses. Building one is something they don't often do in science, but I think that children take ownership of what they're learning by building their own model oven and testing it. The difficulties of supply and demand, actually trying to understand why on earth it should be difficult to actually run power stations. What's the problem? It's not immediately obvious that there is a huge challenge in delivering electrical energy to people's homes. And the challenge is forecasting how much they will need.
What's excited me today, I think, was actually getting the live data from the national grid. So to be able to bring that, we all already look a little bit at the graphs with supply and demand, but the fact that you can actually look at real live data, what's happening at the moment, I think that's been really, really beneficial.
Really fun demonstrations, the coat hanger rather, that span around and lit up the fluorescent tubes. That was very cool. And so was the the big discharge basically that happened between the earth actually and just a one high voltage electrode. It was very dramatic to see that.
Well, the national grid are facing huge challenges. We've got a lot of infrastructure that's outdated and needs replacing. But also with wind farms, for example, and wave power coming online, how is all that generation going to get into the national grid? And the connections haven't been made yet. Our students in the future will be the engineers of the future, and they're the ones that are actually going to solve lots of these problems. So teachers have got all that to take away to engage their students, and also some nice little bits of scenarios of energy supply and some graphs and some data, lots that they can actually use in lessons. We've developed some practical activities, and we'll take them through those practical activities and get them confident in doing that hands-on stuff. And some of that's quite tricky with models of power lines and transformers, and some of them might not have confidence in doing that sort of practical work. So we will take them through that and get them to do it themselves, and look at other practical applications of solar cars and wind turbines, etc., so that they've got a whole range of practical work to take into school.
I wasn't aware at all that there was such a big shortage in engineering kind of graduates or just good qualified engineers here in the UK, and that we sort of face so much competition from other countries and we're a little bit behind the race. That's very useful to be aware of that. It's the kind of thing that the kids really appreciate as well. If you can say to them, look, you know, you're the future, we're going to need more people who are good engineers in the future, more people who are interested in that sort of thing. It's a good place to go for you. That helps enormously to kind of enthuse them and to make it relevant for them.
We're able to go over to a research area, the high voltage lab, and we can show them electrical engineers doing some real research work, big sparks, flashes, and that will be a real wow. So they can see what engineers are doing some research into and look at the really advanced and sophisticated equipment that they're working with.
We've definitely been given lots of ideas about career progressions for students, and particularly in directing them towards careers with the national grid and in other areas of engineering around that. It's broadened my knowledge of the career path to get students into that direction, and of the potential careers that there are out there for them.